Every AI model you use has a knowledge cutoff, a date where its understanding of the world just stops. And the reason isn't laziness or cost-cutting. It's a problem called catastrophic forgetting, and it's more fundamental than most people realise. Here's what most explainers miss. People assume a neural network stores facts the way a database does, one fact per slot, neatly filed. It doesn't. A neural network stores everything as overlapping patterns of numerical weights. The same weights that help the model understand French grammar also contribute to its grasp of organic chemistry and 19th century poetry. Nothing is stored separately, everything is entangled. So here's what happens when you try to teach a model something new. Say you want to update it on events from the last 6 months. You feed it new training data, and the learning process adjusts the weights to encode that new information. But those weights were already doing something. They were holding the patterns for everything the model previously knew. Updating them doesn't add to the old knowledge. It overwrites it. The analogy I find most honest is a palimpsest, a manuscript where the original text has been scraped away so someone can write over it. You can still write something new, but the old text is damaged or gone. This is catastrophic forgetting. It's not a bug in a particular model. It's a structural property of how neural networks learn. Train on new data, lose old capabilities. Researchers have developed workarounds. Replay buffers mix old training examples back in during new training. So the model practices its existing knowledge while learning. Elastic weight consolidation identifies which weights matter most for prior tasks and penalizes changes to them, essentially putting guardrails on what the learning process is allowed to touch. Modular architectures try to sidestep the problem entirely by giving different tasks their own dedicated parameters. Each approach helps, none of them fully solves it. This is the core reason AI models can't just stay current the way a search engine can. A search engine indexes new pages without touching old ones. A neural network can't do that. Its knowledge isn't indexed, it's woven. And that distinction shapes everything from why models have cut-off dates to why updates require retraining from scratch rather than a simple patch. If that was useful, subscribe. New Explainer every week. I'm Ariella.